Question 6. Now, if you have not carefully revised your double angle formulas and done lots of questions associated with double angle formulas, you are almost certainly not going to be able to get any marks in this question. Trig equations, trigonometry, people say it's hard. It's one of the hardest bits of the A-level maths, people say. Perhaps, but if you're well rehearsed and you've done lots of practice, it shouldn't be, because there's only so many different tips and tricks that you can use, and sometimes it's not obvious which of those to use, but you can simply try them all until you find one that helps you solve a problem. So these become solving puzzles, really, rather than horrifying A-level trigonometry, because once you know and you're familiar with all the tools, you just got to just try them until you can until you can solve it. So part 1 here, before we actually solve that, we're going to need to know our double angle formulas. Now, these can be derived from the compound angle formulas in the formula sheet, or you can commit them to memory. It's going to be quicker if you commit them to memory. If you forget, you can work them out from the compound angle formulas. Those are the ones that start sine a plus or minus b in the formula sheet, and simply by letting a and b both equal x, and look at the right hand side and you can see what it is. But seriously, commit them to memory. Here they are. Sine of 2x is 2 sine x cos x. There's only sort of one version of sine 2x, and that's it. Whereas there are several different versions of the cos 2x formula. The standard one that you generate if you use the compound angle formula is this one. It's cos squared x minus sine squared x. But normally, you need to use a version of that formula where you've replaced cos squared x with 1 minus sine squared x. Therefore, the whole thing becomes 1 minus 2 sine squared x. Or you replace the sine squared x with 1 minus cos squared x, which gives you 2 cos squared x minus 1. The way I remember which one of those is 1 minus and which one is thing minus 1 is, well, we're dealing with the cos double angle formula here, and the cos one has the cos 1 positive on the right hand side. That's just how I remember it. Very occasionally, but I wouldn't worry too much about this one, there was actually a fourth version of this, which is to spot that this one is the difference of two squares, so you effectively have cos x plus sine x, cos x minus sine x. But that hardly ever comes up, and if it does, then examiners are being really mean. So let's not worry too much about that one for now. I have worked closely with an exam candidate before, a lady who she hated committing these to memory. She felt like she'd always forget them. She could keep in her head for a while. So on the way into the exam, she committed them to memory one last time, and when they said start writing, instead of opening up the question book, she opened up the formula book and scribbled these down, exactly like this, out of her mind into the formula sheet so that she could clear her mind and then start the exam, and if she needed a double angle formula, there they were. Consider doing that, because she said it really helped her. Okay, so let's tackle part 1 then. Use an appropriate double angle formula, given this information here, to find the exact value of sec 2x. Well, sec 2x is, of course, 1 over cos 2x. So we really just need to work out what cos 2x is, and then we can calculate sec 2x. Now, which of these three formulas are we going to use? Well, which information have we been given? We know sine x, we don't know cos x, we know sine x. So it makes sense to use this one here, which has only got sine x on the right-hand side. So cos 2x equals 1 minus 2 times the square of sine x. Now I've written it like that just to show the substitution clearly. So it's 1 minus 2 lots of the value given in the question squared, which is 1 minus 2 lots of 9/25, which is 1 minus 18/25, which is 7/25, and therefore sec, I'll do it over here actually, sec 2x is 1 over 7/25, which is 25 over 7. Final answer. Okay, part 2. Let's come over here for that. Now I'm going to prove this fairly ugly looking equation. Now, this can make it look even more ugly. What on earth does that mean? Well, it's just there to make sure that this is even solvable or can even be written as an equation. Don't worry about it. What it actually means, x is not equal to any multiple of pi over 2, because if x was equal to a multiple of pi over 2, then one or more of these terms here is undefined. That's all it means. Here it's just saying n is an element of the integers, which is just saying that this is integer multiples of pi over 2. Don't worry about it, it's not important. It's not like it's even a domain for a function or anything, you just don't need to worry about it. So, prove that cot 2x plus cosec 2x equals cot x. Prove that, and it's an identity. When you're proving an identity, it's customary to pick the most complicated looking side and see if you can force it to look like the less complicated looking side, because we're used to simplifying things, not making things more complicated. So it makes sense here to consider the left-hand side. Now this is where that experience and practice kicks in. It's really helpful. Because here's what a lot of people wrote in their exam. They wrote this, which isn't wrong. There was actually, in fact, a mark available for this. But people who wrote this tended to then get stuck. Because what do you do now? Well, what you could do is you've got the sum of two fractions, and clearly on the right-hand side in our target expression, we've only got one expression, so it would make sense now to combine these into a single fraction. But here's an easier thing to look at. Instead of cot 2x being 1 over tan 2x here, whoops, I meant to highlight that. Instead of this, it's actually easier to note that cot 2x is in fact cos over sine. So cos 2x over sine 2x. Because if you spot that, you've instantly got your common denominator that you need. Fantastic. So let's write that as a single fraction. Now, we still need, on the right-hand side here, it's cot x, it's not cot 2x. So we're going to need to use the double angle formulae to be able to simplify this in a way that works. So the denominator, nice and easy, because there's only one formula that you can use for sine 2x, so 2 sine x cos x from here. The numerator, we've got some options again. But since it's cos 2x plus 1, it makes sense to use this identity here, because the plus 1 here is going to cancel out with the minus 1 in the identity in the double angle formula. So I'm going to write 2 cos squared x minus 1, which is cos 2x, plus 1, and then rewrite that, of course, as just simply 2 cos squared x divided by 2 sine x cos x. Give yourself a bit more space. Let's come back over here. Our 2's cancel, And one of our cos x's cancels as well, so we end up with simply cos x over sine x, which gives us our cot x as